Test, Test. Ja, gibt auf jeden Fall die Anzeige hoch.
Sollte läuft.
Hello, everybody on the stream. Can you hear me? Oh, unable to connect to the chat. Das ist natürlich.
Gut, dann haben wir noch angekommen.
Ja, wir sind live.
Was ist das von der Perspektive?
Ja, oder? Ja, vielleicht ein bisschen.
Let's be fast. Oh, but
We're live.
oh, okay. To check the audio.
Yeah, seems fine. So they can hear us. Oh, I should start the other recording.
Nice to meet you. Antler.
Hi, Frank.
Yeah.
So you are the
main star. Sure. No.
You're not Brazilian, but you live in Brazil, right?
I live here.
Yeah.
Why?
Well, I was talking to
Michael.
and I'm Brazilian.
Ah.
Vamos falar português, então. Onde você? De onde? Que cidade?
Sou de Recife,
Recife?
mas eu mudei para São Paulo.
How's Portuguese? So,
Yeah, it's good.
yeah?
But like, did you learn in Portugal or something?
Não, I live in Rio.
Okay.
Tem essa sotaque carioca, sabe? Do eixo do peixe. There is an accent in
Yeah.
Rio de
Yeah.
Janeiro. Recife is a dangerous place. I've been there.
No more than
But
Rio.
very good carnival.
Come on. You live in Rio. You talk about danger.
I think it's more. Recife is more dangerous.
It's more. I don't think it's more, but definitely. I would be more afraid to be. But
Sir? He also
Everybody knows you.
no, just one of the organizers.
Huh?
Just one of the organizers.
Oh, okay.
The microphone doesn't amplify. So it only records, doesn't amplify. Welcome to
Yes.
What's your name?
Anderson. And your name again?
It's very tall to hurt the cats.
Oh, you're gonna use
Misha remembers it well. No, I was just offering it. It's your event. I don't want to.
Yeah,
We'll
sure.
see if it doesn't work.
I'll leave it here. With everybody we have in the office, after a week or two, it's enough to just show it. You don't need to use it. Because
We are
everybody's
about to
trouble.
start. Please take your seats.
You want to open?
Do you want to do it alone?
No. Let's try it.
Hello, everybody, and welcome to the February Go Meetup. Very glad to see so many of you here. Thank you to Antler for hosting us, and for and NetBird, of course, for also hosting us. You have to explain how that short agenda. We will have two talks. First one from our gracious hosts, and the second one from Grafana Labs. In between, we have a short break and an HR Lost and Found and open mic session. So if you are looking for a job, or if you are offering a job, you can have 30 seconds, 20 seconds? What was it? 30 seconds, I think, to go here, come in front of all the people here and present it. So I hope we'll have a lot of participants on that. So with that, I'll hand over to NetBird. Thank you.
Thanks everyone. Thanks for stopping by, and for those who are remote, thanks for tuning in. NetBird is an open source zero trust networking platform, fully written in Go. You can check on GitHub, and if you have some remote infrastructure that you want to connect to, you can try NetBird. And if you don't want to use any kind of firewalls, security groups, if you're tired of these configurations, you can also try NetBird. So we are not at NetBird's office, and we are at Antler's office. So who's Antler? What is Antler? I'm also a Go developer, right? I'm a CEO and co-founder of NetBird, but I started my career as a Go developer, and I was pretty bad with business. So, and I got this idea of doing private networking together with Mike and my co-founder. And Antler was our first investor, and they believed in the project. And Christoph, maybe you can speak a few words about yourself.
Of course. Very happy to. Welcome, everyone. My only role this evening is to give an office for you guys to meet, and obviously say hello. My name is Christoph. I'm a partner with Antler. As Misha said, we were lucky enough to be the first investors in NetBird, and we're also the first investors in a little bit more than 1,500 other companies. So in our portfolio, you'll find not only cybersecurity companies, you'll find direct air capture companies, you'll find payments companies, you'll find all sorts of both hardware as well as software companies. This is not about us. If you want to learn more, if you are building something cool, if you want to start a company, just scan that QR code and hit us up. We'd love to meet you, and we'd love to dive deeper, not tonight, but maybe some other day. Looking very much forward to the evening. Thank you all for coming.
Thanks, Christoph. So, private networking. So I'm going to be talking today about private networks. And at the core of NetBird is a high-performance peer-to-peer network based on WireGuard. And the big part of private networking is DNS. So I'm going to tell a story about our fight with DNS management on Linux, and a few issues we encountered, especially related to a default DNS port. And here's what we'll cover today. I'll briefly explain the need for DNS in private networking. Then we'll jump into the local DNS implementation in Go, the DNS port 53 issue on Linux. A quick overview of two technologies that we use to solve this problem that are eBPF and XDP. Yeah, and how we integrated this whole thing in Go. To set up the context, when it comes to private networking, you have, especially peer-to-peer networking, you have two machines that want to establish a direct connection, right? They need an IP address, a private IP address in order to communicate with each other. And who defines this IP addresses? It's some sort of a coordination server that can run in the cloud or wherever, it doesn't really matter. So it assigns these IP addresses to the machines. At the same time, it can assign a private name to each machine so that it's easier for me as a network administrator to access a server, for instance, in this private network. So the task of DNS resolution, so when it comes to accessing private resource, is pretty much to resolve a private name, something like server.private.network, to a private IP address so the machines can communicate. Looks very simple, right? So what are the ways of implementing the DNS resolution? So one way is a centralized resolution, pretty much like any public DNS server. You know, Google has DNS servers, Cloudflare. But when it comes like to millions of devices, it can be quite a challenge to scale it. And also it's a privacy concern. You know, we don't want to have users leaving traces on this public service. Another option is to keep a local hosts file with all these entries, like private.server.network, database.server.network, in a local file, host file. Same thing, you know, it's not scalable really. It can outgrow pretty quickly. And also, you know, how many times did you configure it yourself? Like, how many times did you put some entries there? You know, it is a little bit messy. So the best way that we think is to run a local resolution process, which is pretty much an application, can be written in any language, that runs on the same machine, like on a laptop, on a server, and resolves local DNS queries, and keeps the entries in memory. So this private.server.network is in memory in this application. So this is, by the way we chose at NetBird. And you know, when it comes to implementing these kind of things, you look for some solutions. You open ChatGPT nowadays and say, okay, how can I implement a DNS resolution in Go? And one of the answers is this great library by Mikhail. It has like 8,000 GitHub stars. You can check it out, but it gives the framework to implement a local DNS server, or maybe not even local, a public one. So it's a great library, check it out. So we used it to implement the local DNS service. I'm not gonna dive into the details of the implementation, but this is how it can look like. It looks really similar to HTTP server. So you have listen, stop methods, you have a handler, and for each namespace, like private.network, you can register a handler that will handle the DNS requests. They're called questions, by the way, in the DNS notations. And this handler has to implement one method, which is serve DNS. It receives the request, tries to resolve the record, finds this record in its in-memory storage, and returns the response. So pretty simple thing. This one at the bottom I just put here because I wanted to show what kind of parts we used from that open source library. So one of them is serve multiplexer. So it pretty much matches the zone name, like private.network, to the registered handler. You can register multiple handlers for any type of zone name. So it can be private.network, can be private.internal, corp.internal, whatever. So, and it will pick up the proper handler. The other one is server, and same thing as HTTP server. You can configure some parameters like IP address, the port, certificates, etc. So not a complex thing. So once you have your local resolver, you need to start the resolution, right? So what you're going to do on your local machine to start DNS resolution? So first, you start the server, right? So that's the default DNS address, loopback address 127.0.0.1, port 53. That's an important port. We'll use it later. So you start the server, and the second thing is to configure the system, basically place a DNS config in the system to tell the system that it needs to resolve private.network namespace with this resolver, which is the local resolver. Very simple thing, right? So there's nothing complicated. But there is something complicated, actually. Do you know what this is? Or you have an idea? Distros, yeah. So these are the Linux distributions timeline. And actually, the list goes down there to the seller. It just didn't fit on the screen. And it represents all the forks and different versions. And when it comes to Linux, the configuration can be tricky, and some things are done weirdly, and one of them is the port 53. So on some systems, on Linux systems, this port is hard-coded. So you cannot change this port. So when you can change the IP address, you can say whatever address, but port 53 for DNS resolution stays the same. And obviously, this brings a problem that this port can be occupied, so by some other process. And when it comes to private networking, you want to make sure it always works, and it always works everywhere, even in some old, like a server in a cellar somewhere in a corporate environment. So there can be some unbound process running or Pi-hole process running on some local machine, so that occupies this port. What to do in this case? There is a trick. We call it unassigned loopback address trick. So, and you know what is loopback address? It's this one, 127.0.0.1, and an assigned loopback address is an address in this range. So it can be something starting from 127.0.0.2. And when you listen on port 53, by providing an assigned IP address, an assigned loopback address, actually Linux actually allows you to listen on multiple ports. So, Linux allows you to listen on the same port by multiple processes. So you can pretty much start two listeners listening on the same port, but with different IP addresses from this range. And to demonstrate this, I created this program. You can actually, I don't know, take a screenshot or try it yourself. So I create two listeners. One is the loopback address listener, the standard DNS listener. And the second one, unassigned loopback address, 127.0.0.153. And I just want to test if I can start two processes listening to the same port. And it actually works. So if I run this code, I successfully created a UDP listener on port 53, 127.0.0.1. and 127.0.0.153. So great, problem solved. Not really. Why? There is a problem that if there is a process that listens on all interfaces of the operating system. So it can be that the system has multiple network interfaces, Ethernet, like Wi-Fi or some others. And in this case, this trick doesn't work anymore. So if you run something, if there is a process running listening on all interfaces on port 53, you cannot have another process listening on port 53. And remember, we need this port because we cannot configure it, and we need to actually configure the resolution. To test this, I just modified this program, added this all interfaces listener to the list, and I can run the program. It creates this listener, all interface listener, but the second one, the loopback, doesn't work. Address already in use. So, and this is a problem, right? We cannot run our local resolver, and therefore we cannot resolve this private.network namespace. What to do? We can use XDP and eBPF. So this is something, if you're not familiar with these tools, these are great tools. eBPF allows you to run custom programs within the operating system, within the kernel, without actually modifying the kernel. So you can put your application, not your application, but some part of your application, some code inside the kernel, and for example, work with packets. It's a pretty limited environment, it's a sandboxed environment, but it allows you to process things within the operating system, which is much faster when you compare it to user space applications. So you do things in the OS without this context switch to the user space applications. And XDP helps you to intercept and process network packets right after they exit the physical networking interface. So before they actually enter operating system. So you receive a packet, and then you can capture it to do some operations, and combined, you can, combining XDP and eBPF, you can actually modify the packets. So you can override the ports there. And this trick we used to solve the problem. This is a high-level overview of the solution. I'll guide you through the flow, but first thing, what we did, we run a local resolver listening on port 5053, which can be actually a random port. It doesn't really matter. But we listened on our private interface, and that's actually an important thing. So this is the IP of our private interface. Then the second thing, you would configure the resolver, the operating system to resolve private.network, our namespace, with a resolver. We call it fake resolver, listening on port 53. But actually, there is nothing listening there, and that's why it's called fake. So we just told the system, listen, resolve this private.network by this non-existent resolver. And that's a configuration. So what happens next is that DNS client, for example, a browser, when I type in server.private.network, I requests the operating system to resolve this name. The system tells it, okay, use this resolver, the fake one. And at this point, the system will go and enter the network interface of our private network. And since XDP is the program that can actually capture these packets, we can catch the packet, take this port 53, override it to our real resolver, port 5053, and send this packet forward to the resolver that will do the resolution and then provide the response of this resolution by looking up the memory, the entry for this one, and will respond back. The problem is that this port is unknown to this client, right? Because it originally was told to go here, to port 53. So with the same XDP and eBPF program, we can modify the source port of the response back to 53 and send it back to the client. So that's the idea of the solution, and it works. So that's not Go. You can actually, that's a BPF program. It's written in C, but you can do BPF programs in Go, but I think it requires some mental capacity because you have to work with registers, and it's just really unreadable. And I don't have it, and our team doesn't have it. So we use C, but we can use these programs from the Go application, and I'll show you how it works. The program is very simple. So you have two functions, pretty much, or two things that it does. So when there is incoming DNS request, we check the destination port, and if it's our general DNS port, which is the default port 53, and the IP address is out of our private network, we override the destination port with port 5053, which is our resolver port. Then we tell the program to pass the packet forward. XDP pass means it's all good, just move forward. And the modified packet goes to our resolver. On the way back, that's the second part that the function does. It checks the source port and also this IP address, this IP, and it overrides the source port to the default port 53. So super simple. One thing that you probably notice is this read settings, and this is the way, this is the function to pass the parameters from Go application or any user space application to the BPF program. So in BPF, you can use BPF maps. That's pretty much a shared state, a shared storage. It's a map that is accessible for your user space application, Go application. In our case, it's a Go resolver, and a BPF program. So it's a shared database. And there we can configure these parameters like our interface IP, the ports. And here, for example, there is a map lookup, and we are looking for the DNS IP. We get the value. Here we do the lookup for the port, and we got the value. That's simple too. So in order to use the BPF program from Go, you need some structures, right? So you need some code to do it. We used a tool called BPF to Go, written by Cilium. So it's a cool tool that you can use to generate Go structures, Go code to load BPF function into your user space application. So this is how it looks. Check this out. It's an open source if you haven't heard of them, but they have been, I think, all over the place when it comes to eBPF, right? So very popular tool. And what it does, it generates some code that helps you to load XDP and eBPF programs into, pretty much to start them, load into kernel. Then it helps you to work with maps, that's shared state. So here, for example, I use this BPF objects, which is a bunch of structures that the BPF to Go generated, to put a value of the IP into this map, and then this value can be used by the BPF program. Here, I put the DNS port, and the same thing happens. This value can be used later by BPF program. And I mean, there were lots of other things around, like error handling, but it's for simplicity. I omitted it for simplicity. Yeah. And now this load XDP function, this is where this loading of a BPF program happens. So you load the BPF project object. So pretty much the program, and then you link this program to XDP hook and attach it to the interface, network interface. So this is how it works. And that's actually pretty much it. So the problem looked very simple, right? So just resolve some private name to an IP address. But in fact, usually, your engineers behind simple features lays a complex backend, right? Yeah, all the code of NetBird is open source. So especially the DNS part, so you can check it out. netbird.io/netbird on GitHub. QR code. We have like 12K GitHub stars. Maybe you can give another one. Yeah, truly check the code. I mean, it's lots of things, but I think it's worth it. And we are also hiring. So if you want to do this kind of stuff, check it out as well. Okay, thank you guys for listening. I hope. Yeah, questions. So do you guys have any? So why does DNS uses UDP? Sorry?
Why does DNS uses UDP protocol, not TCP?
I mean, you can use this is a common protocol. So, and actually, when you define a resolver, you can specify protocol, right? But that's a common one.
Yeah, maybe to add to that, when DNS was introduced, we needed something that was very lightweight and performant, because it's the first thing that a computer does when you go to a website. So it needs to resolve the IP address to access that, and needs to be something very fast and performant.
And maybe for that reason, to make it fast, they also hard-coded the port 53.
Thanks for the talk. Quick one for me. So whenever I come to the system that runs NetBird, how do I find out that there is something that runs this eBPF program that rewrites my port to some other ports? How do I reverse engineer it if I don't know?
It's actually Mike and the CTO can answer this, but it's a very good question.
Yeah, good question. Thank you. So by default on Linux, we fall back to eBPF. So is the standard. You can use eBPF tools, like a BPF tool is the name, to check that. But the only case that we don't use eBPF on Linux is when you run a container and you have limited resource. And then we fall back to different ways of managing DNS resolution.
Yeah. Also, to add on that, we also use NF tables and IP tables to do the firewalling, and we will probably migrate to using eBPF for that, because it's actually much easier to maintain the code and without checking all these dependencies and stuff like that.
Yes, so we've got a question from the chat from Krishna. Does the BPF application block the port 53 for itself? And if not, how does it skip processing the packets that are actually supposed to go to 53?
It doesn't really block. So maybe here. you configure the system to resolve the queries. So to resolve this config, the private.network, to go to this resolver. So anything that is going to 53 that doesn't match this IP actually is processed normally. So you don't override anything. And this is what you can see in this command. In this code. Pretty much here's the matching. And if it doesn't match, it just pack it forwards and goes to the default 53. And XDP program doesn't occupy port. It just catches the packet and redirects it. Another one there? No? Okay, I think you were first, but we'll...
Yeah, I mean, I'm just curious. First question is, which distro gave you the biggest headache? And I mean, on top of that, like the second follow-up is how everything works with Mac. And the third one is, how do you test? How do you know that all the solutions are like? How do you test everything? Like, how do you know that all the distros are covered and everything works?
Wow. Okay, so what was the first one? This distro. Actually, I don't really remember, but I think, was it Debian? Yeah, really, I think even Ubuntu actually from 2020, or earlier, they don't have this port 53 configuration. So it's just 4 years old, right? Was it the case, right?
Yeah. So basically, the default resolver on Linux do not support any custom ports. So it's been like that forever. So they just use 53, and you can set any IP address. And if you go to etcresolvers.conf, you're going to see that you only have a field for enter the name server address. That's why we decided, okay, we need to take a approach that's going to be supported by many distros and going to give us less headache. In case that this is not possible, because some old kernels will not support XDP, for example, then we fall back to different solutions. Or maybe we even don't, as a VPN product, we do not support DNS resolution on that system.
Mac question, it's not done, it's done differently. So it's user space network processing. So it's fully in user space, so it's fully in Go. And there you can actually catch the packets and just do the whole thing right in Go code. It's much easier, but it's not as cool as in here. And the testing. Man, I think you should just go to the GitHub repo, and there are lots of tests. And we run CI/CD pipelines, so different operating systems on GitHub. So we try to test every possible case, kernel, non-kernel, like whatever, Docker in Docker. So you just have to spin up machine and test it, That's
exactly, especially for eBPF. So eBPF is maturing now, and we are starting to see more and more tooling around tests there. But for our case, we are relying mostly on end-to-end tests for that.
Okay, there was a question there too.
Thanks. Okay, one is to complement the question. You will say Linux, you say Mac. Okay, how was on Windows? And the other question is, I remember back in the time, systemd, resolved was supposed to solve all these problems. Was that the case, or actually it created more problems?
It's like with JavaScript, every day new library, and then you have to support one more thing. So I wrote an article on that, and there pretty much there is a breakdown on the common ways to configure Linux, DNS in Linux, and there are like 4 that you can use. So, and one of them is systemd. So it's just another way, but it's a good one. You can also communicate with it with dbus from Go directly, so you can throw comments there. So it's kind of okay. But still, you need to support older systems that don't have it. So anyway, you just have to support few things. Windows, it's the same as Mac, so it's user space. It's the same on iOS, on Android. It's a user space packet processing. Easy stuff. Yeah.
Yeah. So how do you provide the DNS resolver address to the client? Do you hard code it, or how it happens?
This is the coordination server. So if you talk about NetBird in particular, that's a So that's a coordination server that is responsible for assigning IP addresses, and it just dedicates a range for the network. And it generates a name from a namespace, and it's pretty much a namespace is fixed in the coordination server, and the name of the machine itself is generated from the host name. So, but in the end, it can be anything, right? You can come up with something random. So, do we have some time for questions? Okay.
Thank you. I was just giving a cursory look at the GitHub repo, and I noticed that NetBird also uses, just like Tailscale, like stern and turn, and also it's doing net traversal. So I was wondering, like, what's the difference between these two? Because in case of Tailscale, the coordination server is abstracted out. Like, we don't have access to that. But here, what is happening? Like, do we control the coordination server as well? Because we're saying that this is open source. So I was just wondering, like, where does the coordination server live?
Good product question. The coordination server can be used, like we have a cloud-hosted one, so it's the easiest way to get started. But you can also host it yourself. So you can host the whole coordination server, which is supported by us. You can host it on your machines. You can also host all the relay servers yourself. So, and there is actually in the repo, there is a script. It's just one single line that you can run, and it provisions everything. The only thing is that once it comes to the production deployments, you would probably want to scale things, high availability and all that stuff. So you'll have to take care about these things. But it's right there, so you can try it yourself. Yeah. Someone had a question.
Thanks. You casually mentioned that we configure private DNS resolution, private DNS zone resolution to this IP address. Does this work consistently across all of the distros, all of the systems? Like, not the port, but the IP address of the resolver. Do you have any issues there?
Oh, so maybe Mark, you better take it.
So the port is working well on most distros, but one thing that is not bashing, but a complaint on Linux is that every distro have its own philosophy, right? So we run into problems sometimes, but usually we try to circumvent them with a different alternative to that. So if we cannot listen on that fake address, which is actually the IP address that we assign on NetBird, we try to do we try to listen on loopback interface, and in some cases we even use a fake address which is not really present on the machine that should go to another place, and then we use that. It's like the third option, and it's more like a fallback. And for Linux or for different operating systems as well, like Mac and Windows, we're trying to make the software very resilient, because we're gonna see that everybody customize the machines, and we need to try to account for that when releasing.
Yeah, there is a if then statement, like, and we literally read the etc resolve conf file to check what resolvers use, and then there is a statement if like this, then we do this, if that, we do that, and it kind of works, you know. So some brute force approach does the job, but it really covers 99% of the cases. More questions? Wow, so many questions. Didn't expect that.
Yeah. Thank you very much. Sorry. Thank you for your job as well. Just the question about the DNS over HTTP. If I just configure it in my local machine to everything having kind of the secure way, will it also work as well? And what will be happen if on the same network my colleague just spin up one more NetBird application and with a different configuration? And this point, how it will work?
I'll start with the second one. The two NetBirds won't work at this on one application unless it's on one machine, unless it's in a Docker container. So you can run multiple Docker NetBird instances on one machine. Regarding the first one, I didn't really get it. Mike, did you get it?
Yeah. So right now we can potentially use a DNS over HTTPS as an upstream server, and it's something that is on our plans to develop and deliver that. But the idea on NetBird and the whole peer-to-peer mesh VPN is that a administrator set a DNS server for the network, and we basically override that. So if you have a DNS over HTTPS, because we are connected to the network, we override that, and you start to use our local resolver for that.
And let's take one more question and wrap it up. Maybe two.
Is this mic working?
Yeah, it's
Hello?
It's going through the stream.
Okay. So, so it's for the streaming. Okay. So my question, I have never used this eBPF. So I see like we would like to trap the whole network traffic and do some modifications to the traffic just to trap this DNS traffic, right? So this DNS traffic might be less than 1% of the total traffic of the whole traffic going through. Do you benchmark, or have you seen any kind of like latencies? Are you still able to use the line rate? You know, there is a terminology called line rate. Have you tested the line rate after adding this piece of code? And another thing, like when you're using Golang, what kind of bottlenecks are you facing?
Golang is perfect. But to your question, first question, it's actually faster than user space. So, but Mike, on that one, on the link.
Yeah, so eBPF and XCP are quite fast, really. It is really low latency. You just kidnap the traffic for a brief period of time. And when you develop a program on eBPF, the kernel makes sure that you're not going to spend a lot of time processing a packet because of that. So XCP is being used very heavily on some companies because of that, because the nature is really a very low, a very high performance program that you attach on the kernel, kind of like a JavaScript to the browser, and you can do modifications on that. That's the guarantee. Sorry? No, we didn't. Yeah. And you want to talk about Go in general?
Go is perfect.
Yeah, exactly. I think that we as a company try to do so much things with Go. We even did a UI application. We did a very core code for the mobile, and Go actually enabled us to do all these things. Looking back, I think that maybe the GUI application was not the best idea, but we have a very simple and nice looking app.
Yeah, we wanted to do the website in Go, but man, you cannot do this thing in Go that nice. So you had a question, right?
Yeah, thanks. It's a question about how you provide the scripts, the BPF program. So you have to compile it for a specific version of kernel. And so do you precompile for all the possible versions, or you compile in runtime when you set up your product?
You actually precompile it. And I think it doesn't really matter It is supported from specific version. I don't remember, to be honest, what version. But you precompile and you just load it into kernel. I cannot show it, but in GitHub repo we actually have this programs precompiled there, and you can load them with Go. So it's all there.
Yeah, you could use CI/CD to generate the bytecode, but we just found it simpler to use that to precompile and push the bytecode altogether.
Since what version does like we support this BPF? I think kernel 5.11.
Yeah, I think so.
Yeah.
Something like that. I don't remember.
Or maybe it was because of WireGuard. Never mind, guys. Okay, so thank you so much for your questions. It was really great. Should we have a break?
Yeah, we will have a break in a minute. Yeah. We will have our famous, I want to say, HR less than found before. So if you are looking for a job, if you have a job to offer, if you are looking for contributors to your open source project, or are looking for an open source project to contribute to. So we will want to give you 30 seconds. Do you have a timer, maybe? And you'll get the mic, even if it doesn't amplify in here. And yeah, can talk about your offer. Anyone? Yep.
Okay, so just looking people for my team. We have, I don't know how many requests per second, but we are on the top 500 websites. The site is called Just Watch, where you can actually find where to watch the film. So it's quite simple thing, everything in Go, Postgres, and basic things. But I think it's fun. You know, if you're looking, juniors, seniors, just let us know. Oh wait, I have now. 3, 2, 1. Now.
Thank you very much.
Who else?
Anyone else? Come on. Do you have to? Yeah, share again.
Okay, thank you. So at NetBird, we are looking for software engineers with a network background, and we are also looking for contributors as well. So if you are looking to start and Go or network in general, you can also look into our repo. Is kind of well organized. I would say it's a mono repo with a lot of things, but we try to put the code there, organize the code there, and should be a very good place for you to start as well.
Thank you. Anyone else? Okay, then 3, 2, 1. No? Okay. Then thank you very much. We are going to have a break, let's say until 8:40, so 20 minutes. And then we'll assemble here again for the second talk. Please grab some pizza, grab drinks before they freeze. And yeah, see you soon. I think now it's... Can you still hear me? Oh, yeah, there's still... Again. Hello, stream.
Like that's how I did my two contracts. I entered credit for like security. We actually figured out
How do I pronounce your name? Goutham. Goutham. Yeah, Goutham. Yeah. Okay. I always try to say the name, and then I always like blank if I so. Yeah, so I'm at Grafana. He's a product, so different companies as well. Okay, so it's a collaboration. Almost, yeah.
As a Prometheus was one.
Blended working.
One more minute.
Yeah.
That's good.
So the mechanical launch mechanism is on the top. So I can really read the time in 15 minutes. Okay, so essentially I haven't used the watch in ages, so I really bought it now. So we'll use it. And it's like 840. So 850, it doesn't jump, it like smoothly goes. But it doesn't have a very clear view exactly.
Yeah, sure. Sometimes it's kind of good.
Yeah.
Yeah, we can slowly hold them back.
I'm so tempted. Intrusive thoughts.
What was that?
Some air horn. Should we do that? I'm so tempted right now.
I want to try hard.
But I'm working. Okay, I have intrusive thoughts, and you just go through them. That's all. Just going to like.
That's even better. So.
Last class on stage in front of like 200 people, so this is fine.
This is fine.
Okay, now let's get to our second talk.
Attention, we're continuing.
We have support from technical support here. Yeah, from Prometheus, you wanted me to say? Okay, so from the Prometheus project, we have two amazing speakers, I hope. Goutham and Matthias. So, and they will talk about governance or something. That sounds interesting. So, a round of applause.
Hello, everyone. So I'm Goutham, and that's Matthias, and we're going to talk about a very
technical topic about Prometheus governance. Introduction, I'm a Goutham. I've been a Prometheus maintainer for about 7.5 years now. Yeah, I joined Grafana Labs to work on Prometheus, did 5 years of engineering, got a little bored, had a little crisis, moved to product management, did that for 2 years, realized I still don't know what PMs do, so I'm coming back to engineering now. Yeah, but while I was a PM, I wrote a lot of docs, and part of that is the governance as well. Yeah.
Hi, I'm Matthias. I'm on Prometheus team as well. I think I got onboarded like 2021. We'll dive into all of that. But I've been writing Go since 2015. I've been part of the Meetup early on, I would say. Haven't been around much lately, unfortunately, due to COVID as well, I think. But yeah, I work at a company called Polar Signals, as you can see on my shirt, and we do Go, a lot of eBPF stuff as well, to basically use eBPF in the kernel to build a continuous profiler, and we ship that off to a Go backend and server database, columnar database, yada, 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 all the good stuff. But yeah, like when I'm not working on that in my free time, I do fun things like writing a governance and hacking on Prometheus as well, because I think that's something I like and enjoy to work on. Handing it back.
Yep. I signed Matthias up for this talk on Monday, and he's like, it needs to be a Go talk. And I was like, no, it doesn't need to be. But yeah, we are having Gophers in the slides to make it a Go talk. Yeah. No, I hope this kind of gives you a glimpse into how open source projects work, like behind the hood. How many of you are not familiar with Prometheus? Okay, one person. He's right. So he said, like, there will be one hand and we'll have to do it anyways. So Prometheus is an open source monitoring system written in Go. It's part of the CNCF. Interestingly, it does not have a single backing company. Like, it's basically a bunch of companies, and it's an open governance. Like, there's no one company kind of controlling the direction, or a lot of the investment being driven by one company. Like, it's just basically a bunch of companies. It started in 2012, 2013 at SoundCloud in Berlin. They didn't want to pay a big observability vendor, and it was a bunch of ex-Googlers, and they were like, okay, let's just build a new monitoring system, and that's kind of how it started. And then, yeah, it was released in 2015, 2014, something like that. And yeah, it's now the default monitoring system when you're using Kubernetes and cloud native. All right, so I'm going to tell you the story of how I became a Prometheus team member. So 2016, I was in college, I was doing an internship, and I was given the task of deploying Prometheus. So I deployed Prometheus. Turns out they did not know what to do with me, so I had a lot of free time. So I sent this email saying, okay, I'm deploying this Prometheus thing. It has not gone to production yet. But I'm like, okay, I started looking at the storage engine internals, and I'm like, maybe I can improve this storage engine. I was like, okay. And this was like June 2016. And somebody, Fabian, who later became my mentor, replied saying, hey, actually, you're right. There is a lot to improve in the storage engine. I have a proof of concept here. I would be excited to do a hangout with you if you are interested in this topic. And in typical new contributor fashion, I completely ghosted this guy. Because again, they figured out what to do with this intern. So I got busy with that. And of course, I did not update this thread. But later, next year, I was like, I don't want to do an internship. I want to do Google Summer of Code. I want to do kind of work on open source projects. And I was looking through the list of projects, and I found Prometheus in the list. I was like, oh, I know this thing. I tried to interact with these people. Wait, oops, yeah. So I sent them an email, GSOC guidelines and proposal format. And funnily enough, none of the maintainers of Prometheus actually knew GSOC was happening or what it was. Mainly because CNCF signed up for GSOC and never actually told the project. So I kind of had to explain everything to them. But this was, 1 year later, I was looking for an open source project. And this started off in March. I started contributing a bunch of things, and I kind of
wrote a proposal of all the things I want to build in the summer, the 3 months of Google Summer of Code. And as it turns out, my mentor Fabian, he realized that through GSOC he has to do evaluations, and he's like, this feels like school. I don't want to do this. I'll do one thing. I'll make my company, CoreOS, which had an office in Berlin, hire you. You do the same exact things. We pay you the same exact money, but you get to come to Berlin for a few weeks. How does that sound? I was like, holy shit, I've never actually traveled outside. So I came to Berlin in the summer of 2017. I experienced 3 weeks of Berlin in the summer. It was magical. I did not realize what the winter would be like, but this was me in 2017. This was all the people I was working with. I don't know what we were doing with the cupcakes, but yeah, this is Fabian. And yeah, these are all the people working on various CoreOS projects in the Berlin office. And then I came to Berlin, and most of the Prometheus team was based out of Berlin because the project was created in SoundCloud, which was also the Berlin office of SoundCloud. I think they only had one office. And they were like, hey, Goutham's here. Let's go have lunch with him. And of course, they were like, oh, Goutham's Indian, so let's go eat Indian food. So we all went to this, we all went to this particular restaurant called Amrit. And yeah, this is in Kreuzberg. It was very disappointing because yeah, but okay, I mean, everyone else enjoyed it. But okay, fine. But then we were all like, we ate, we had fun, we were chilling, and they were like, hey, we should add Goutham to Prometheus team. What do you think? And somebody was like, yeah, we should add Goutham, and should also add Max to the team. What do you think? And then they basically sent an email to this group called Prometheus team, saying we should add these two, and then basically they added me and Max, and that's kind of how I became a Prometheus team member. And yeah, Matthias.
Yeah, it's kind of like a similar story to some extent. I think most in the sense that like it happened almost at the same time. I don't know, am I unframed? I better go over here. So I basically was in college as well in 2015, and I definitely wanted to write a lot of Go code. So I like attended these meetups. I like looked for jobs eventually to write Go, and I found this company called JustWatch. I interviewed with them because I think they were like among the first 5 companies in Berlin who like actually started writing Go back in 2015, 2016. So that's how I found them, and that's why I started working at JustWatch. And kind of like on my first day, they were like, yeah, we have this thing called Prometheus. I was like, okay, whatever that is, but fancy dashboard. So I was like, oh, intrigued. That's great. So basically my first couple of days were just write more Prometheus exporters. I eventually took over the Elasticsearch exporter by the end of 2016. Which wasn't really maintained. So like I maintained that. I brought it into JustWatch on GitHub. I maintained it for like a year and a half or two, and then eventually now it's donated to Prometheus community, where like all of the community maintained projects under the Prometheus umbrella are kind of like confined these days and somewhat better governed and looked at. And I've been always around in kind of Prometheus land. So like Goutham and I think like in 2017, when you did all of this, like we started also meeting, even though I wasn't in team, I wasn't really involved. I was just enthusiastic about all of this. And I went to KubeCon 2018 in Copenhagen, met everybody there. I always hung out, and eventually, next slide.
No, but I want to also point
Yeah.
out that
Yeah. Yeah, like Frederick on stage is now my boss at Polar Signals, and I basically joined as the first hire there. And I was like, okay, I want to work at this cool company called CoreOS because they do lots of great stuff here in Berlin. They have an office, they write Go, they write Prometheus stuff. Turns out I was just a couple of months late with my thesis, so I started working at Red Hat instead. And then I got to work on the Prometheus operator, Prometheus. I don't know if people have used these projects. And then there was this new thing called Thanos, which was like a scalable Prometheus, super new back then. So I started contributing to that and working on that back then as well. And eventually, even though it's fine. So eventually, like 5 years later, being around all the time, Richie was like, "Yeah, we should just add Matthias to Prometheus," even though he has never like actually contributed to Prometheus as like the core project. But I've been around like every time. So eventually, I got into team, and now I've been organizing the Prometheus Meetup, even though we haven't done it a lot since COVID. And then I also organized PromCon, the conference for Prometheus, twice. So that's kind of a bit of the backstory and the past.
So why were we telling you this story? So to give you a little bit of context, 2017 Prometheus, I would describe as a jolly bunch of people. It's just, there was no significant commercial interest. It was a project out of SoundCloud, and they built a monitoring project, and basically SoundCloud was putting it in maintenance mode. And there was this huge community adoption, but most of the people that worked on Prometheus worked on it in their free time. There's one person who built a consulting company around Prometheus, and there was one person at CoreOS being paid full time, but that's it. It's kind of interesting, like people were like, okay, I like the node exporter, and suddenly they're the maintainer of the node exporter. Somebody wants a new feature into the node exporter. If the node exporter maintainer doesn't think it's fun, it's probably not going to get done. So it's kind of interesting. And if you contribute long enough, you're now part of team. Like, there was no real formal governance around this. If the team feels that it's good enough, okay, you're now part of the team. And then the Prometheus project joined the CNCF, and one of the things about the CNCF is you need to have a very formal governance. It doesn't need to be like super long, but you need to have something written down, something public. So yeah, that basically happened. CNCF kicked off the discussion in July 2017. So right after I became an informal YOLO member at Amrit. And then basically after 6 months of discussion, they kind of finally merged it in Jan. So how does the V1 looks like? So lazy consensus is the default mechanism. It's kind of interesting. So because there's a bunch of people working on Prometheus in their free time, if I'm really excited about a project, I propose it. And if nobody replies, approved. And that's kind of the state of things. Now, if somebody replies and says this is a shit project and we can't kind of resolve the conflict, that's when we resolve to votes. And I think in the 7.5 years, we probably voted on 3 things. So we really kind of defaulted to consensus, lazy consensus as the default mechanism. Again, also because there weren't like 50 people trying to build the same thing. There's like one guy trying to build one thing. Well, there's 3 other things that also need to be built. So yeah, adding members to the team, core team, is kind of voted in through a super majority. So 2/3 of the people need to say yes within a week. And because we just had team, we didn't have a hierarchy, you become a team member, you have full admin on everything. You get this one password, and with one password, you can do whatever, like including delete the website. Yeah. So how do you become a member? It says you have to have ongoing contributions for at least 3 months. And usually in the form of code improvements, but like significant ongoing contributions for 3 months. It's vague enough that, if somebody should ideally notice you. You can't propose yourself to become a team member, but somebody ideally needs to notice you, notice that you're working consistently, you're showing up, and then basically they add you. In the case of Matthias, it took us 5 years. Yeah, so it's not very ideal. I just happened to have lunch at an Indian place and I'm in, so, yeah, so what does team member kind of give you? Honestly, nothing much. You get to merge PRs. You can do that as a maintainer. But like if you are a team member, you have full admin on anything. You can YOLO push. That's something I've done. Yeah, we used to have a private dev summit for all the team members, but now it's open. So anyone can join the dev summit where we kind of discuss various topics. But mostly it's admin work, like dealing with CNCF, organizing conferences, like kind of like doing like PR or some like admin work around like writing new blog posts and stuff. What it did afford me is bragging rights, and I got my job at Grafana mainly because I'm a Prometheus team member. Cool. So now we get to the present. So this is like 7.5 years later. Hate it. All right.
Let me take the clicker as well.
Yes.
Basically, as you can see, like in 2012 it was started, and then nothing much happened. And in 2016, like somebody I think randomly posted on Hacker News or something, and it's like started blowing up. But yeah, it's been growing and growing and growing, and yeah, just crazy to kind of like these days go back and look back at it. But it's been growing like crazy, and you can see the contributions over time for the past like 5 years, and lots of contributions. And the chart was going down, so crazy amounts of contributions. But then you can kind of see it dipping, and just in the past year we kind of like taken up the actual kind of trajectory in terms of contributions again. So while the project was growing, there were like growing pains, I think, and that's kind of what we're like seeing here, kind of like proxied through these stats. At least that's what we were thinking. And you can also see kind of like the overall contributing companies and developers not really growing anymore. So that happened like the first like 5 years or 10 years. And now we're like at this point where we feel like we need something new, better, and evolve the Prometheus team, right? So we want Prometheus to still grow. And we think that looking at all of this, we have come to a point where we need something better. So enter the new Prometheus governance, and when was this? August 20th. So
basically, I was looking at all these charts. I newly became a PM. I was looking at charts because that's what PMs do now. And the chart was going down, and I was like, holy shit, something really bad kind of happening. And I wrote this document which kind of lists out all the problems of the Prometheus governance. Yeah.
Right. Well put. So yeah, the problem is like we don't have a clear path to membership, and that's kind of like, yeah, have a lunch at Amrit, or like, I don't know, be around for 5 years and you get into Prometheus team, but it's like not really formal, and we still want to have people become part of the team, become of the kind of like inner circle, if you're just doing good work and you like contribute for a couple of months, right? We have like some hesitation to add new members because, I don't know, we think we need to know them personally or something, various reasons. But also, yeah, like various companies.
No? It's also like if you add someone, they get full admin on everything. So we need to really trust them as the project kind of grew in popularity. The second thing is to make any change, we need 2/3 majority. And if we felt like if we have too many inactive people, we would never be able to hit the 2/3 majority. Yeah. And yeah.
Sure. And then, yeah, we don't have like that. I guess that's part of it. Like we don't have roles on, like we don't have like any hierarchy or like way to organize any of it. And then, yeah, there's like, even though I like everybody at Grafana Labs, including Goutham and everybody else, like I know Grafana since like they were like 20 people or something. So like a very friendly company to me, but kind of just Grafana putting so much time and effort into Prometheus that it's like hard for any other company kind of to compete in terms of like active contributions and stuff. I mean, I think also everybody who's using Prometheus should be contributing back and should be kind of like getting involved. So I think that's also a sign that like, yes, on the one hand side, like Grafana is like contributing a lot and it's causing kind of over-representation, but I think it also is a problem that too few companies contribute to little.
To also add to that, internally we had a lot of discussions. We want to make sure that Grafana never has more than 50% kind of voting power in the project. Like we want to make sure that Prometheus is not seen as a Grafana project. What this meant was the newer people who come to Grafana and are contributing to Prometheus they have less of a chance to make it to team because, Goutham has been there for 7.5 years, which is extremely unfair for all the new people that were coming in.
Especially a lot of those people do put in more hours these days than like both of us combined. So yeah, like anyone, like all of this needs to change. You can read the full doc here, I think. And the future is hopefully bright. We want to go away from these like 30 team members, and we want to scale it up to 300 diverse people on Prometheus team. And kind of like, I think it was like 1.5 years ago, like the first PromCon that I organized in Berlin, everybody from Prometheus team came together at Google, and we sat down and we were like, something needs to change. We need to evolve this Go project in the right direction. And then everybody agreed on it and nothing happened because like everybody was like, not the most fun work.
Oh yeah, this doc is absolutely great, like amazing. Just we should do this new governance, but nobody was volunteering, and we were all looking at each other. And somebody said that you need someone young and naive to do it. So again, so I looked at. I was like looking around. I looked at Matthias. I was like, okay, and then I was like, okay, I'll step up. And Matthias.
Yeah, like by then I was like, okay, if I do this with anyone, like why not do the new governance with Goutham? Should be fun, should be interesting, and maybe we can like work together on this. Like even though it's not the most exciting thing, like we get to meet like every couple of weeks, and I don't know, go to like different food places afterwards and have a couple of beers. No, of course not. So yeah, how did we tackle it? We looked at various different projects.
Yeah, we looked at Core DNS, which is a very small project. We looked at all the various different governance structures that different projects have and wanted to pick the best out of all. So Core DNS has a steering committee of 5 people with at most 1 person from one company, and the maintainers of Core DNS get to pick the steering committee. Now, which means it's a small group of people electing an even smaller group of people. We looked at Kubernetes, which took me a while. ChatGPT didn't exist 18 months ago. So they have like SIGs and working groups, and they have like a clear escalation path for everything. And yeah, like their escalation path looks something like this. So you have a sub-project, and if you have disagreement in the sub-project, there's a special interest group. If there's disagreement in the special interest group, there's a subcommittee. If there's disagreement in the subcommittee, then it goes to the steering committee. And I was like, oof, this is just quite a lot of complexity. Like we are like a jolly bunch of people who are like, oh, we feel good about this person, let's add them to team. We don't want to go from that to like super complex. So yeah, but they have a steering committee that's elected by all the active members who vote. Active members are members who have like 20 contributions in 12 months or something like that. There's also the Knative project, which we picked. I don't know why we picked this project, but we did. I think it's a serverless project or something. Yes, it's a new governance change. So they had a steering committee with contributors, active contributors voting. They had a technical committee, and I didn't really understand the difference between technical committee and steering committee. But I just checked recently, they don't have a technical committee anymore. So even they didn't know what to do with it. So yeah. And then we have OpenTelemetry, which is a steering committee with active contributor voting. And even they have a technical committee. We looked at all of these. And then we kind of had a fair idea of what we wanted. We wanted a steering committee. That way we can have like 7 members, 5 members in the steering committee, and like a 300-member team without like any one company over-representing, and like, you know, we can't hesitate to add people and stuff like that. So yeah, I want to give a shout out to the CNCF. They have this SIG contributor experience, and they kind of have all these templates. So we basically went from something that looks like a maintainer council to something that looks like steering committee elections. So we kind of modified the template to whatever we think works well for the Prometheus project. And we basically went one-on-one with everyone in the project, because there's a lot of members with a lot of feelings. and we didn't want to kind of put it up at a group setting. So we went one-on-one with each, kind of spoke to them, took their feedback, explained the proposal, incorporated that feedback, kind of like did this. It took us a little bit of time. And then basically we came with this governance, which we will now go through line by line. No, just kidding.
Yeah, like we had to do it like multiple times, so we'll spare you the pain. But yeah, like this is basically what we came up with. As Goutham said, like we'll have the steering committee. We kind of like decided on 7 individuals from at most 2 from the same company, and then all of these get voted for by members and maintainers, and basically everybody else just starts out as a contributor. So if you have ever sent a pull request to any of the Prometheus projects, you already are a contributor. That's literally it. And then how you become a member is that basically you start contributing quite a bunch, and then we will put in processes in place, like we'll actually automate all of this, and then some automation will tell maintainers of new members that are quite active and propose those new people, these contributors, to become members. Members basically, like they don't get a lot. Yeah, they don't get a lot of. Next slide. Nice. Yeah, so they don't get a lot of rights, but like basically bragging rights, just like we have right now. Yeah, like you get the Prometheus logo on your kind of GitHub profile and stuff like that, right? So you can say like to your employer, I need more time to work on Prometheus, for example. So that's why we're doing this, and we want basically just 20 contributions in 12 months is kind of like the baseline, and once you like get over that, you can become a Prometheus member going forward. And comments count, meetups count, and blog posts also count.
Not attending meetups, organizing and giving talks at meetups.
Yes, yeah, fair point. So yeah, the current maintainer nominates. Will probably, as I mentioned, like kind of automate this to make the life of a current maintainer easier, to not kind of like lose track or have somebody slip through the cracks. And then
if you can become a maintainer if a current maintainer nominates and no existing maintainer complains. Yeah.
So basically the idea is that like a maintainer now is like, we don't have this like one Prometheus team for everything where like 30 people are in there, but like every single project has their own maintainers and they kind of like self-govern within that project. So it should be a lot more flexible and a lot quicker to do these things going forward. And then once you are a member, like this is like basically the only additional right, you get to vote on the steering committee. So or become part of the steering committee. That's true. So once we kind of like, so let me, like if we have bootstrapped everything, the steering committee will be in place. There will be 7 people, and those 7 people we will have for 2 years, and after 2 years we will have 3 people start fresh, and then a year later the other 4 people will start new and start fresh. So like we'll have like some time where they overlap, but we don't like vote for 7 new people at once. So that's why we have like, yes, we have 2-year terms, but we will kind of like stagger the steering committee so that they can like effectively continue working over time. And the members, they vote for these steering committee folks, basically saying, okay, we trust these people to take care of like admin stuff, like talking to CNCF, or if, worst case something happens, they need to resolve conflicts, etc. And just earlier today, because of this meetup, I think, this is always how this works, Goutham actually copied everything from our Google Doc into a Markdown file and pull up the Prometheus governance 2.0. So even though you might not be part of Prometheus team yet, you can still review and suggest changes to the Prometheus governance 2.0 and take a look at how we can govern this project going forward.
It's on the GitHub repo, GitHub Prometheus/governance. It's a new repo that we created. Yeah.
Yeah. You want to take this?
So one of the things is we wanted to have the maximum amount of representation as we kind of vote for the new governance. Governance changes needs 2/3 majority. So we looked at all the active members, maintainers that are not team members yet, and basically voted them in. So we have 21 new team members. We went from 30 to like 55 or something like that, which is pretty good. But the funny bit is they get to become team members, and they get to vote on the new governance, and then they go back to being members. So, but no, we wanted to have maximum amount of representation, kind of feedback before we did this change. So if the new team does not like the governance that me and Matthias spent 18 months on and off working on, they get to reject that and build a new one. All right. I just want to give a call out for this. The next thing me and Matthias need to do is automate everything, adding members, removing members, permissions and stuff. So we were looking for tools that does GitOps, but for GitHub permissions. And CNCF built this thing called CLO Warden, and they built it in Rust. Like, it's like a Python project or a Go project, but like a Rust project, but fine, like, you know, okay. Exactly. Someone wanted to write some Rust and they get to build it. So yeah, okay, cool. But yeah, we will probably be using this. Matthias can write some Rust. I can do ChatGPT, so we're good. How are we doing for time? All right. So I just want to give very few quick tips of contributing to open source that I think works for me, works for new contributors. First one, start small. Like, pick up good first issue, easy issues, like start small, answer user questions. Like, you don't need to start like somebody opens a bug, verify that bug exists, probably kind of say, hey, this bug exists in probably this package, something like that. Like, start small, verify user issues, answer user questions, like kind of get a feel for the project and understand what's kind of not working with the project. I do this with every new project. I put a lot of print statements and run it again and again and again and again and again, just to understand like which bit lives where. I have not found out how to use a debugger. Like, when somebody uses a debugger, I was like, whoa, magic. Yeah. So 2 or 3 easy issue PRs later, look for bigger pieces, and typically you will have like one package that you kind of have a little bit more familiarity with. So look for that and look for like a bigger change. Ask people, hey, you know, now I've done like 2 or 3 small ones. Is there like a medium one that I can kind of pick up? And yeah, like, it needs to be more than just code. Like, you know, you can't just pick up issue after issue after issue. You have to like answer user questions. You have to like help triage issues. You have to come up with new ideas on where the project has to go. This is kind of how you go from just a committer to kind of, oh, this person has good ideas. This person is doing good work. Let's make them a maintainer. Let's kind of like elevate them. So yeah, I wouldn't limit it to just code. Like, it has to be a holistic contribution to the project. Ask for help. This is always the first step, but my recommendation is ask for help after you spend 3 hours troubleshooting how to fix this issue. Like, typically people are like, okay, I want to help with this issue. Tell me how. No maintainer is excited to do that, like, honestly. But what is more exciting is you try to fix that issue. You try 3 or 4 different things. You bang your head against the wall for 3 hours, and then you do a write-up saying, hey, I've tried to use this issue. I've looked at this file, this file, this file, but I still couldn't figure it out. And when you write that, the maintainer will be guilt-tripped. I'm like, holy shit, my code, somebody's struggling to debug it, like, you know, for like 4 hours now. I need to go help them. So yeah, like, guilt trip the maintainers, put in the work, and then ask for help. And be consistent. Like, don't be like me. You put a message saying, let's rewrite the TSDB, and then disappear. So yeah, like, you have to be consistent. You don't need to work full time for 3 months or anything, but like, just be constantly show up like Matthias did, like in various different places. And hopefully it won't take you 5 years to become maintainers for the project that you want to maintain. Yeah, and Prometheus has a wide surface area and a lot of opportunities to contribute. So we have the exporters, like we have like 1,000 of them.
Like super nice stuff.
Yes.
Like they have a super small surface.
The exporters, like, you get to be like, I don't know, Elasticsearch, right? You already are super familiar with Elasticsearch, so you dive into that specific exporter and you just need to know a bit about Prometheus and you can start contributing already, exchange that Elasticsearch to anything that you already know, and you can already start contributing, right? So like exporters are super, super nice to start contributing with.
Yeah, that's I think that's basically everything that we have. Thank you.
I don't know if we have questions. You can also ask Go questions about Prometheus.
Thank you very much. Like maybe do you have any metrics or values? How long, how much time does it take to open the pull request, getting like requesting change, getting approvals, and finally merge?
Correct me if I'm wrong, but I think there's something in the dev stats, right?
Yes. There's something called CNCF dev stats. I think devstats.cncf.io. And for every single CNCF project, they have all kinds of graphs, including the ones that you saw, like basically who's contributing, how much did each person contribute, what PRs, what is the mean time to merging a PR, what is like mean time to first response to a issue. All of those metrics are being tracked. I just don't know what they are. I'm not a PM anymore, so, you know. Yeah.
You showed the metrics of the contributions. There was a big gap in October 2021. Do you know what happened?
Data issue.
Well, like that's actually influx in the backend.
And then it's not posted. But it's kind of interesting. We kind of decided to take a look at this year at this point. And then we also decided to do Prometheus 3.0, kind of get a lot of the new fresh ideas into the project, and then eventually did it, and I kind of want to keep that trend going up there.
Yeah, sorry.
Oh, okay. Are you done?
Yes.
Okay. Yeah, question from the chat from Dave. What are the major challenges in maintaining Prometheus as a community-driven project?
all the above. I don't know. Major challenges. I think like you want to like embrace everybody who's coming in, but like we don't have the governance in place to do that. So I think that's why we like saw the need to like put in all the hours to rewrite the governance. I think that's a super big one. And then otherwise, I think it's just like always like there are many different companies with various interests, and we want to be very conscious about a single company not overthrowing everybody else. So I think in Prometheus, we've done a super nice job in doing that over the past like almost 10 years. And I think this is like something. Anything
and
else?
I also want to add, like, because very few people get paid to do Prometheus, the activity that they have is super bursty and super inconsistent. And that's something that we live with. Like, we can't expect somebody who's not paid to kind of like work on Prometheus full time. So we kind of like have someone who comes in who does a lot of work, and suddenly other people have kind of offloaded it. But like when they leave because something happened, maybe they changed a new job, maybe they found an exciting project, like there's a vacuum that we need to fill, and it takes a while to fill, and everything just like drops on the floor. But it's okay. It's an open source project. If somebody has an issue, open a PR. Yeah.
And just a quick question. I know you're working for Prometheus, but what is the relationship with Thanos and Victoria metrics?
Yes. Long political answer, or no? Like so Prometheus was this like 2012 project started at SoundCloud, and basically it was like the first version of the storage. Then Fabian, who mentored Goutham, basically came up with like the new storage version 2 that is pretty much used to this day. In 2018, I think 2018 he wrote basically all of the Prometheus storage.
2017, actually, yeah.
yeah, and Goutham was kind of like instrumental in that as well, and various other people. And then because of the new storage architecture, there were things that weren't possible before, kind of like using the Prometheus blocks that are being written to disk to also offload them to object storage. So that's how basically Thanos got created, because Fabian saw the opportunity to like basically take Prometheus and make it horizontally distributed, scalable, and offload things to object storage. So that's how Thanos got started. Kind of like one of the Prometheus maintainers started Thanos, and then some other people like kind of like chimed in and started it as well. Cortex was already there before that, which basically, I mean, it's still a CNCF project, but kind of like, I hope this is not recorded. Mimir basically took over the Cortex scene, right? And is maintained by Grafana. So that was always there, and there was always the push system. But even Mimir these days also writes to object storage. So kind of like there are various different approaches to kind of like scale Prometheus. And that is what Mimir and Thanos are. And then Victoria Metrics came in kind of like out of the scene and kind of like started some different project, some additional very interesting things, but they also broke a lot of compatibility with Prometheus. And yeah, that's kind of where we're at with all of these projects.
And I want to add, Prometheus kind of took a stand that we are going to build this highly reliable single binary that you run on one system and you vertically scale it. And there are a whole ecosystem of projects that you can like kind of scale out Prometheus. And there's Thanos, Mimir, Victoria Metrics. And Prometheus explicitly decided not to be like a kingmaker and say, you know what, Prometheus endorses Thanos. So we're like, okay, we're going to help the community thrive and may the best project kind of win for different use cases. So Victoria Metrics is, even though not 100% compatible, I think they're like very much a core part of the community, and we do want to see the project thrive.
Thank you. You said you want to focus on expanding the team with a focus on diversity as well, but also you want to automate the membership editions. How do you plan to tie that in together, the automation?
Mm-hmm. Very tricky, yeah. I mean, it's always a good question. I think we can just like make sure we had many like contributions from a diverse group of people, and we kind of failed to quickly like nurture those contributions and get them onto team quick enough. So they kind of like after that, like they lost interest again. So that happened quite a bit, unfortunately. And I think that's something where like if we encourage people to contribute and they see kind of like, oh, this like these people are super happy about the contributions, and like we also take them into like the inner circle basically more quickly, then I think we can kind of like turn down the churn there of people just going away again. That unfortunately happened quite a bit. But good question. All right.
Cool. Yeah, thank you very much. It was interesting, so well done. Yeah. At least one. Yeah, thank you very much for coming. That's it for the official part of the meetup. Is there any pizza left? No? Yes? I don't know. But maybe there are some drinks left, so grab those. And thank you very much for coming. I hope we can have the next meetup next month. It's not fixed yet, so not entirely sure, but yeah. Thank you to Ole for moderating the live stream. And yeah, see you soon.
And as always, if you want to give a talk to us. The link is on the Meetup page to submit talks. You can talk direct to us. Also, if your company wants to host the Meetup, same thing. Talk to us, message us. You're going to find us in the Gopher Slack, and our contact is on the Meetup page. You can find us. Thank you very much.
Thanks for organizing.
Somebody says longer. Thank you for talking.
Yeah.
That was so hard. Yeah.
No.
bureaucracy involved in organizing meetups.